What's going on, everybody? It's Mr. Gus. I'm in the physics conference room today. We're talking about simple circuits and the OhmMyLab. This is a basic circuit, okay? It's going to have a power supply, some wire, and one resistor. Now, schematically, we might draw it like this. We would have our battery or our voltage supply. It would come out. We would have our resistor here, and we'd come down. Now, the other thing we're going to do is we're going to be measuring current. So somewhere along the line, we would have what we call an ammeter, or a current measuring device. This is our schematic. This is how we would draw it on paper, but I'm going to draw it a little bit differently so you can kind of see the materials. If you weren't in class today, here's what the materials look like, and here's exactly what we did. So we have our power supply. We call it a battery eliminator, but this is our power supply. It basically turns on the force that pushes charges through, right? It's my voltage supply. This is our power supply, okay? And it's got two terminals in it, a positive and negative, that will have wires sticking out of it. So we did this, right? We went ahead and we put a wire here and we ran it all the way, and then we clipped it with the alligator clip to one side of a resistor. And we took the other wire out of the negative terminal and we clipped it to the other side of this resistor. Now I have a couple different resistors. I have a 10 ohm resistor. I had a 5 ohm resistor in class. We had both of these. We could put any resistor we want there. And so this is our setup. Now we turned it on, and the power supply has got a dial for changing voltages. So we started at 1.5. We can change it to 3. Let's go ahead and list out the data we should have taken today in class. So we have the voltage or potential produced by the power supply. The voltage, I got 1.5 volts I can use, 3, I can do 4.5, I can do 6, I can do 12, and I can do 15. These are the voltages that get produced. Now, our job today in class was to measure the corresponding currents for each of these, right? So, voltage, this will be current over here. This is measured in amps or amperes. All right, so our job here was to do this for two different resistors. So we'll have this as our, we'll start with the 10 ohm resistor, right? So first we'll call this our 10 ohm data. So I got it plugged in. I've got my 10 ohm amp resistor here. I somehow need to measure the current using my multimeter. So what we have to remember, if I look at my schematic shows that my multimeter needs to be in line, right? So my battery wire comes out, my wire runs through the resistor. This is what a resistor looks like, runs through the resistor, then runs directly through the entire ammeter, through the entire multimeter, and then back to the battery. So the multimeter has got two wires. It's got one coming out of the 20 amp terminal and one coming out of the common ground terminal. If I wanted to put this device like this in line with my circuit, I would have to break this circuit somewhere to line it up. So what I did is I would break my wire right here. I would take this off, and I would run this wire and connect it to my ammeter right here, my multimeter. So I'm going to connect the wire out of the negative terminal into one side or the other. Quite frankly, it doesn't matter. We'll still get a reading. I connect it here. Well, that's when I'm going to take the common ground, because now my charge is flowing through, the voltage is producing this push, is the charge is flowing through this wire, it's going through my device. I need to connect this wire now back to my resistor. If I look at this, I've got my power supply, I've got my resistor, and I've got my multimeter all in the exact same loop. If I look at my schematic, I've got my battery, my power supply, my wire, my resistor, and my multimeter all in the same loop. These two things match. So now, as I go ahead and I dial up my voltage at the power supply, the reading will produce exactly what I need, and that's current. Let's go ahead and take some sample data. Obviously, this circuit isn't going to work, so I took the data in class and wrote it down. For the voltage at the 10 ohm resistor, the current will be 0.15, 0.3, 0.45, 0.6, 1.2, and 1.5. So go ahead and pause. This is data that we would get for current through this circuit if these were our voltages at the power supply and this was a 10 ohm resistor. Pause it, write it down, call this resistor 1 for yourself, okay? Because now I'm going to change this to a 5 ohm resistor which means the data is going to change. We know that if there's less resistance in the system, current should go up. There's less resistance to flow of charge, the charge will move faster, and the speed at which this charge moves, coulombs per second, is the current. So let's go ahead and change this now. So my data's going away. If you need that data, go back, pause it, figure it out. All right, last data. So now I've got 5 ohms. If it's a 5 ohm resistor, remember this was 0.15. With less resistance, now the first current is actually 0.3, and this is 0.6, this is 0.91.2, 2.4 amps, and finally 3.0 amps. So you can see with less resistance, when I replace that 10 ohm resistor with the 5 ohm resistor, my currents increase. I'm getting more current because there is less resistance given the same force or push of charge from the voltage. Again, a voltage or a battery produces an electric field in my circuit. An electric field is a predictive value of push, right, of force. So that voltage produces the push, pushes charge through my circuit that already exists, and then the rate at which those things flow is known as current. So we've got that. All right, your job now is essentially to graph these two things. So in order to graph these things, let's go ahead and graph it with our dependent variable on the x-axis first. That was voltage. I was in charge of voltage. It's measured in volts. We measured current. That's I. It's measured in amps. If we go ahead and graph this, let's go ahead and call 10 ohms a dotted line. Let's call 5 ohms a solid line. If we go ahead and graph this, what we find out is that it's a line. Here is my 5 ohm resistor, and its slope is right around 0.2 amps per volt. And if I go ahead and plot my data for the 10 ohm resistor, its slope ends up being 0.1 amps per volt. Now that's a pretty interesting setup I got. That's pretty interesting numbers, right? Given the resistors that I have, 10 and 5, this is a pretty interesting slope. One thing that I'm noticing is the slope of my 5 ohm resistor is 0.2, and the slope of my 10 ohm resistor is 0.1. Let's go ahead and make an equation of this, right? My equation would be the y variable, I, equals the slope times v. All right, this is my slope here. This is my equation, right? Whatever the slope is. So I'm trying to figure out what this slope is. I don't know what it is, but I do know that 0.2 can be rewritten as 1 over 5, and 0.1 can be written as 1 over 10. This is really curious because I have a 5 ohm resistor and a 10 ohm resistor. The slope of this graph is actually 1 over the resistance of that resistor. Now, if we rearrange this whole equation, right, I could bring R over here. What I end up with is V equals current times resistance. And this is a law we have in physics known as Ohm's law. Oh my, Ohm's law. This is the big idea of the lab. Our job was to determine the relationship between current, voltage, and resistance. It's Ohm's law. Okay? If you got questions, ask me about it. Obviously, finish the lab in your lab notebook. In your packet. Questions, drop in the comments, send me an email, ask me in class. Now we've got Ohm's law. We can go ahead and start using it. All right? Until next time, see you.